Hi class, we're going to finish our study of chapter 3, talking about parallel and perpendicular lines by moving into section 3.7. So this is finishing coordinate geometry, and this is talking about equations of lines. So just like the last video, excuse me, this will be a longer video. We have 4 objectives in this section. The first is we want to use the slope-intercept form that I briefly talked about in the previous video. We want to use the point-slope form that I also talked about in the previous video. And then what we want to do is we want to write equations of vertical and horizontal lines, and then we want to find equations of parallel and perpendicular lines. And now I have a bunch of examples in this video for you, but also your textbook has a lot of other great videos, and the My Math Lab, especially when you're working the problems this week, using the show me show me an example or help me solve this will help a lot. All right, so here are the forms of linear equations. The first one is the slope-intercept form of a linear equation. So this is the y is equal to mx plus b. Here the slope is m and the y-intercept is that b. Remember the y-intercept is a point where the x value is 0 and b is where it crosses the y-axis. This y minus y1 is equal to m times x minus x1. This is what we call the point-slope form of a linear equation. We have the slope m, and the point x1, y1 is any point on the line, literally any point. This ax plus by is equal to c is the standard form of a linear equation, and here a and b are not both 0. A horizontal line, so that lies flat, is literally just the equation y is equal to c. So the slope is 0, that's why there's no x in it, and the y-intercept is 0 comma c. So a horizontal line is just y is equal to the c value here is wherever it crosses the y-axis. A vertical line, the slope is undefined, right? And then the x-intercept is some point c comma 0. So an equation for a vertical line is literally x is equal to some number c, and this is where it crosses that x-axis. So I encourage you to keep these handy as we go through this lecture. All right, so just literally just a bunch of examples from all of these equations here. Write an equation of the line with y-intercept of a point. The point of the y-intercept is 0 comma negative 3, and the slope is 1/4. All right, so we're given the slope and the y-intercept, so I'm going to let m, the slope, be 1/4, and b be this negative 3. And I'm going to write the equation in the slope-intercept form, y is equal to mx plus b. So here it is, y is equal to mx plus b. I'm literally going to replace the slope with 1/4 and the y-intercept with that b value of negative 3. So plus minus here, I'm just going to write it as y is equal to 1/4 x, 1/4 was the slope, and instead of plus negative 3, I'm just going to write it as minus 3. And that's it. So let's talk about now how you graph this. All right, so I want to graph that line I just found, y is equal to 1/4 x minus 3. So the y-intercept is 0, negative 3. So the y-intercept is going to be the point on here. All right, so let's graph the line. So to graph the line, plot the intercept. So I'm plotting it right here. You should see the black dot just come up on negative 3 on the y-axis. Now start at the y-intercept. And now what we're going to do is we're going to use the slope. Now remember, slope is rise over run. So I'm going to rise 1 unit. All right, so notice the blue goes up the rise 1 unit. And then I'm going to run 4 units because it's rise over run. So up 1 over 4, just like when we talked about the slope in the last section. So then what I'm going to do now that I have 2 points, because I rised 1, because that's the rise, and then I ran 4 for the slope here on the bottom part, I'm just going to draw a line through those 2 points. That's it. And that's all you have to do to graph the line. So plot the y-intercept, then rise and run to find the next point on the line. All right, let's take a look at this one. All right, so I'm just saying, hey, graph 2x plus 3y is equal to 12. But what I want to do first is I want to get it into that slope-intercept form. So I'm going to take this and I'm going to move the 2x over, right? So that I get minus 2x plus 12 here. And then I'm going to divide everything by 3. So the 3 will cancel with this minus 2/3, because minus 2 divided by 3 is that. And then 12 divided by 3 gets me the 4. All right, so what's different about this one, you'll notice, is I have a negative slope, right? So negative slope, When you go to rise, a negative in mathematics is the opposite. So instead of rising, you're going to fall. All right, so the y-intercept here is the 0.04. All right, so to graph the line, plot the intercept. So I'm going to plot the point 0, 4. And now here's where it's weird. I'm going to start at the y-intercept, and I'm going to rise -2 units. So I'm going to go down 2 units because I rise -2, so you're going down. And then I'm going to go over 1, 2, 3 because the run is still 3. So down 2 for -2, and then I'm going to run 3 over to here. And that got me my other point. So now all I'm going to do is I'm literally just going to draw the line through the points right there. So whenever you have a negative slope, instead of rising that many units, just fall down that many units. All right, the point slope form. All right, the point slope form of the equation of a line. All right, here, remember we talked about this in the last video. This is y minus y1 is equal to m, and then in parentheses, x minus x1. So m is the slope, and this x1, y1 is any point on the line, literally any point. All right, so find the equation of the line with slope -3 containing the point 1, -5. And then let's write the equation in that slope-intercept form. So the first thing here, we're going to use that point slope form with m is equal to -3 and the point y, -5. So here's my point slope, y minus y1 is equal to m, and then x minus x1. So I'm literally going to plug in -3 here. My y value is going to be, this is going to seem weird, minus 5. I'm going to plug -5 in there. And then I'm going to plug 1 into here. So when you do that, you'll notice you get double negatives. So that's going to become positive. You're going to have to distribute the -3. So this becomes y plus 5, -3x, negative times a negative becomes +3. And then the last thing you're going to do is you're going to subtract the 5. And you get y is equal to -3x minus 2. And that is in that final right slope-intercept form right there. Let's do another one. So let's find the equation of a line through points 4, 0 and -4, 5, and then write the equation in the slope-intercept form. All right. Whenever you want to find the equation of a line, you need two things. You need any point on the line. This is great. I've got 2 points to choose from. But you need the slope. Shucks, I'm not given the slope here. Well, the first thing you need to find is the slope of the line. And to find the slope of the line, you can use any 2 points on the line. So m is equal to y2 minus y1. So this is -5 minus 0 divided by, excuse me, x2, which is -4, minus x1, which is 4. So this becomes -5, -4 minus 4 is -8. Negative becomes a positive. So I've got 5/8. That's my slope. The next thing, you can literally use any line. All right, so use either point. It doesn't matter which one, and the point slope form. So it's going to be y minus y1 is equal to my slope, which I just found, which was 5/8, times x minus x1. Pick the easier point. Obviously, the point with 0 in it is easier. So it's y minus y1, which is 0, is equal to 5/8 times x minus 4. Now, what's hard here is that there's a fraction. So to clear the fraction, multiply both sides by whatever the denominator is, which is 8. So y minus 0 is y, but then when I multiply it by 8, it becomes 8y. 5/8 divided by 8, the 8 goes away, so you're just left with the 5. Now distribute. So you get 8y is equal to 5x minus 20. And then in the last step, literally divide everything by 8, right? Because you want to get the y by itself. And 5/8 doesn't simplify. And 20 divided by 8, well, 4 goes into both of them. So that simplifies to 5/2. And that's your final equation right there. So when you're given 2 points, this one that was a little bit longer, you have to find the slope first. And then you have to go through the point slope form. All right, let's write the equation of a line. All right, so write the equation of the line graphed here and write the equation in standard form. So what you have to do first, if you're just given a line, is you have to pick 2 points on the line. So I'll pick this point and this point here. So the 2 points are -1, 2, and the point 3, 5. So remember what I said. The first thing you need to do is find the slope of the line. Well, that is y2 minus y1, so 5 minus 2, divided by x2, 3, minus x1, which is -1. So don't forget the double negatives. So this just becomes 3 over 4, all right, because 5 minus 2 is 3, and 3 plus 1 ends up being 4. So I've got the slope. Now pick any line, or excuse me, any point on the line, doesn't matter which one. And then just remember here, I want this in standard form, okay? So that's the ax plus by is equal to c. So I'll use either point. So we'll use the point 3, 5, didn't matter which one, all right? So I'm going to plug in the 5 for the y, the 3 for the x, and 3/4 in for here. Remember what I said when you have a 4 in the denominator, or anything in a fraction here? So the 4 is in the denominator, so multiply both sides by 4. Don't forget when you have to leave this in parentheses, so it becomes 4 times this. The 4 cancels, you're just left with the 3. Distribute the 4, distribute the 3, and you get this. So 4y minus 20, 3x minus 9. Combine, or excuse me, send the 3x over, so you get minus 3x, all right, plus that 4y. Now add the 20 over, so you get minus 9 plus 20 equals 11. And this is that standard form. The ax plus by is equal to c. That's your standard form right there. All right, let's find the equation of a horizontal line containing the point 2, 3. Well, remember, the equation of a horizontal line is y is equal to c, and that's where it crosses the y-axis. It looks like it crosses the y-axis at 3. So a horizontal line has the equation of the form y is equal to c or y is equal to b. The line contains the point 2, 3. Well, the y value here is 3, so it has to go through the value 3 on the y-axis. So the horizontal line is just, the equation of it is just y is equal to 3. That's it. Let's do the same thing, but with a vertical line. So find the equation of a line containing the point 2, 3 with an undefined slope. Well, what that tells me is an undefined slope comes from a vertical line, if you remember from the last section. Well, that goes through the x value 2. So a line that has undefined slope, the line must be vertical. So a vertical line has the equation of the form x is equal to c. Well, the x value that it crosses on the x-axis is 2. So the equation of the vertical line is x is equal to 2. That's it. All right, now let's get into some harder ones. All right, I want to do something about parallel and perpendicular lines. So let's find an equation of the line. So I'm telling you the line I want to find has point 4, 4, but it's parallel. This is weird. It's parallel to this line. All right, so remember from last section, parallel lines have the same slope. All right, and I want to write this equation in that standard form, that ax plus by is equal to c. All right, so parallel lines have the same slope. So let's start by finding the slope of this line. So I'll subtract the 2x over, and then I'll divide by 3. So when you simplify here, the slope of this line right here, is minus 2/3. So again, the slope of the parallel line is going to have the same slope. So I know the slope, and now I know the point it goes through. So I'm going to use the point 4, 4. Excuse me. So that my y and my x are both going to be 4. And my slope m, it has to be the same as this slope right here. So just plugging in, again, there's a fraction here, so multiply by each side by whatever's in the denominator. So the 3 comes over here, and the 3 cancels here. Now it's pretty simple. Now just distribute. So you get 3y minus 12 minus 2x, negative, negative becomes positive, so plus 8. Add the 2x over, add the 12 over, so it becomes 2x plus 3y. 12 plus 8 gives me 20. So this is the equation of the line. Let me go back. That is parallel to this. They have the same slope, and it goes through that point right there. All right, let's do one last one. All right, so let's find the equation of a line containing the point 4, 4, but now it's perpendicular. All right, so it's no longer parallel to the line, it's perpendicular. All right, to 2x plus 3y is equal to negative 6. And let's write the equation now. Now be very careful of this, in slope-intercept form. So before we had it in standard form, now we want it in slope-intercept form. All right, so perpendicular lines have slopes that are negative reciprocals. So the slope of this line was found in the previous example. So the slope of this line was minus 2/3. So the perpendicular line has the flip of it. So 2/3 becomes 3/2, and then negative, so negative, negative would become a positive. So the slope of the perpendicular line is 3/2. So I know the slope, I know the point it goes through. So the point was 4, 4, but my slope now was 3/2. So again, fraction, whatever's in the denominator, multiply it by each side. So I get 2 times y minus 4 is equal to 3 times x minus 4. Distribute, so 2y minus 8, 3x, this is a little typo here, this should be minus 12. So pardon that typo there. So then next thing you have to do here is add this over. Okay, so it should be 12, so pardon that. So you get minus 12 plus 8 would get me 4. But then when I divide everything by 2, so the 2 would become, the 3 divided by 2 would get me 3/2. And the minus 12 plus 8 was 4, but divided by 2 gives me minus 2. All right, that was a lot for equations of lines. I encourage you to go back and make sure you watch the videos for the section and also read the text.